to be looking at dividing radicals. Let's get started. The quotient property of radicals is when you have x and y. X needs to be greater than or equal to 0, and y needs to be greater than 0. And here's your x and y that I was talking about. The nth root of x over y is equal to the nth root of x and the nth root of y. So just like our product property, we can squish them together and we can pull them apart so long as we keep the same index, and we keep the same, like if x is on top, it stays on top, and y is on the bottom, it stays on the bottom. Okay, and it's also important that y is greater than 0. Y cannot equal 0, it needs to be greater than 0. Okay, let's take a look at this. I have the square root of 4 over 9. Okay, the square root of 4 over 9 is equal to 2/3, and now I'm going to write the square root of 4 over the square root of 9. The square root of 4 is 2, and then the square root of 9 is 3, so it's 2 over 3. So we can see that these are exactly the same thing. We're just writing it a little differently. Let's look at some examples. So our first example has the square root of 40 over the square root of 5. The first thing we're going to do is rewrite it with one on top of the other. So 40 is on top, 5 is on the bottom, and now I'm going to put them under the same sign. Okay, I have my big square root sign with 40 over 5. I can see immediately that 40 over 5 is just 8, so I'm going to write the square root of 8. Can we simplify? I hope you're nodding your head and you're saying yes, because 8 is just 4 times 2. 4 is a perfect square, so you can pull out that 2 and leave the 2 in the radicand. So 2 times the square root of 2. For our second example, I have the square root of 15 over the square root of 12. So my first step is to write that under one big radical sign. Next thing I'm going to do is see if I can simplify in the radicand first. So 15 over 12 can be rewritten as 3 times 5 over 3 times 4. We cancel those 3's and we're left with 5 over 4. So I'm just rewriting that under the same big radical sign, and then I'm going to separate them again. And the reason why I'm going to do that is because I can simplify it a little bit more. So now the square root of 5 over the square root of 4, and you can see that 5 is a prime number. I can't simplify that, but I can simplify the square root of 4, and that's just 2. Okay, rationalizing the denominator. I know, we're trying to make sense of math, and now we gotta talk to the denominator. It's not making any sense. Someone's gotta talk. Oh wait, it's not that kind of rationalizing. Just kidding. Okay, this type of rationalizing is the process of removing radicals from the denominator of a fraction. Okay, for some reason in the math world, they don't like radicals on the bottom. They like radicals up on top where they can see them nice and clear. Okay, first step is to write the radicals in fractional form, one on top of the other with a little bar dividing them. Step number 2, simplify both the numerator and denominator as much as possible. You're going to do that while they're in the radicand. And then in the third step, if a radical is left in the denominator, multiply by the form of 1 that makes the radicand and the denominator a perfect power. So we're going to talk about the form of 1 in just a moment. I'm just going to go through the fourth step first. Simplify both the numerator and the denominator and reduce the fraction if necessary. You know how we like to simplify things in math. Okay, so my first step, my first practice problem, I have the square root of 5 over the square root of 7. Okay, and I want to, since this is already simplified, I want to multiply by a form of 1. And what that means is multiplying by 1. Now there are different ways that we can represent 1. Okay, we have 2 divided by 2. 2 divided by 2 is 1. So technically, if I multiply this by 2 over 2, I'm not changing the fraction, I'm just changing how it looks. Okay, we do this when we are simplifying fractions, right? When we had that 15 over 12, that was 3 times 5 over 3 times 4, and the reason why we did that, we could see that they had 3 in common and we crossed it out. Well, we're going to do the opposites. Okay, we're going to multiply this by the same thing, by a number over that same number, so it's just multiplying by 1. And I want to change how this fraction looks because I don't want that radical in the denominator. So how do we get it out? Well, I need to multiply by rad 7. Yep, you heard that right. I need to multiply rad 7 over, the square root of 7 over the square root of 7. That will keep it 1. And if I multiply that bottom by the square root of 7, okay, then square root of 7 times the square root of 7 is just, I'm going to give you a minute. Think about it. It's 7. Okay, very good. I hope you got that. So on top, we squished our 5 and our 7 back together. That was our product property of radicals. So that's just the square root of 35 over 7. Let's look at this next one. Okay, can I simplify this? Yes, I can. So I'm going to try to see what I can do to simplify this first. I'm going to break up 15. Okay, 15 I can break up into 3 times 5. So I'm going to put it under its own square root sign. I'm going to turn this into the square root of 3 times the square root of 5 instead of the square root of 15. And you'll see why in just a moment. Okay, I'm now going to rewrite it while they're separated. So 25 times the square root of 3 over 9 times the square root of 3 times the square root of 5. Now do you see why I broke them up? I hope you see it, because we're going to slash it. Yes, so we're just going to slash it. That means we're just canceling out our square root of 3's. Now what are we left with? 25 over 9 times the square root of 5. Okay, like we have that square root of 5 on the denominator. We do not like that. So what can we multiply this by in order to cancel out that radical? And it has to be in the form of 1. That means you're multiplying the top and the bottom by the same number. So the number I'm choosing is my radical. Okay, it's the square root of 5. I'm going to be multiplying by the square root of 5, top and bottom. So now I have 25 times the square root of 5 over 9 times 5. Why would I do that? Besides, rationalizing. Well, look what else I can do. I can simplify it. Again, I'm going to cross out my 5, cross out my 25, replace that with 5, and now I can rewrite my problem. So I have 5 times the square root of 5 over 9. Okay, so that is it for today. I know that went by kind of quickly, so if you have any questions, just feel free to shoot me a message and I will help you. All right, have a very blessed day.